Hello, in this video, we are going to talk about medical optics. Medical optics is part of a bigger field called biophotonics, which combines the study of two fields. One is biology, which is the study of living matter, and the other is photonics, which is the study of light. Now, the basic idea is that we want to shine light onto different things and then, say, measure something about them or to take images, and in the process, know something more about our bodies. One important thing is we use a property of light, which is the fact that we can have diffused light. And the reason why we do this is so that we can do things in a non-invasive way. It is important that we do it non-invasively so that we are not shining, say, harmful radiation or we are not harming the body in any way. We use these properties of light to build devices which can do several different things, like measure the brains of the babies or adults, or we can use them for scanning for cancers, or we can also convert them into these tiny little wearable gadgets which can be put on people which are doing exercise and understand much more about our bodies.
Now that you know what medical optics stand for in general, let me summarize it a little bit deeper by looking into 4 aspects of it, and then I will explain you what we measure briefly. To achieve all the goals that you have heard for medical optics, we rely on 4 properties. One, that the photons can travel deep into the tissues, passing the biggest barrier, the skin, and reaching the organ of interest. Once there, they interact with something in that organ, and then the photons can come out and I can detect them. This needs to be properly understood by proper physical modeling, and proper algorithms has to be in place to recover the information from them. Second thing is that it should carry relevant information. Just because a physicist like me tells you that it's interesting to do this work doesn't mean that there's any real clinical or biological interest. Third thing is that we should be able to deliver light and detect light in a safe, convenient, ergonomic, cost-effective manner that is relevant to the clinical or scientific questions we would like to address. And the fourth, we need to be convincing enough for the clinicians and others to derive the right hypothesis that we can test. We need to have testable hypotheses to go into the clinical settings and test these methods. Now that I have told you the basic 4 pillars of this idea, let me tell you what we measure. We measure things related to oxygen. How does oxygen get to a particular tissue, how it is consumed in that tissue, and how it sustains the proper function of that tissue. And as you can imagine, this is indeed important because oxygen is the core of life. Most living things require oxygen to metabolize and survive.
What is the potential impact of this field? We believe a lot. One of the projects that I'm working on is a Tiny Brains project, wherein we are looking at babies with congenital heart defects and shining some light on their brains. And in the attempt, we are hoping to study more about what happens to their brains when they undergo these complex surgeries. That is, we are doing neuromonitoring. And we hope that we will be able to tell the doctors something more about what can or cannot go wrong with respect to the brain when these surgeries occur, and hopefully prevent them from doing something that may cause harm to the brain.
As you heard, there are a lot of examples related to measuring the brain. There are many other examples as well. For example, one application that us and others have looked into for many years is in the field of oncology. In other words, in understanding how cancer grows, detecting cancers, and its therapies. In particular, we have been working a lot on thyroid cancer screening, in looking into different ways to improve that the clinicians can understand whether a particular thyroid nodule, like a tumor, is bad or a good cancer, to improve these things. We did this by adding ultrasound into our method, such that the doctors can see where the tumor is and optics can tell the type of the tumor. Another area is therapy monitoring and personalization in breast cancer. When one undergoes a cancer therapy now, oftentimes it's done blindly or with a little bit of information through complex imaging methods such as magnetic resonance imaging, MRI, or CT scans or X-rays. If you want to do this more often and try to tune the type of therapy according to the needs of the person, you need to be able to get information non-invasively and more often, and our technologies deliver such a promise.
In this video, we have given you an idea of the importance and impact of medical optics. You will find more content and activities on this platform related to this topic. Feel free to reach out to us if you have any more questions.